Next, let us see example 6.3. A circular coil of radius 10 centimeter. This time we have a circular coil, not a rectangular coil or a square coil. Radius is 10 centimeter, number of turns is 500 and the resistance is 2 ohm, is placed with its plane perpendicular to the horizontal component of Earth's magnetic field. So now what is the magnetic field? Magnetic field is Earth's magnetic field. It is rotated about its vertical diameter through 180 degree in 0.25 second. Estimate the magnitude of the EMF and current induced in the coil. Again we have to calculate the EMF and current induced. Horizontal component of Earth's magnetic field at the place is 3.0 into 10 to power minus 5 Tesla. Let us solve this problem. So we have a circular coil. Let me make a circular coil. So here is this circular coil. Now what is radius? Radius is 10 centimeter. Okay. How many turns are there? Let me make more turns. There are more than 1 turns and number of turns is 500. So we have 500 turns. Now this, what is the resistance? Resistance is 2 ohm. Resistance is 2 ohm, number of turns is 500 and radius is 10 centimeter. With its plane perpendicular to the horizontal component of Earth's magnetic field. Let us say Earth's magnetic field is in this direction. This is the direction of Earth's magnetic field and especially horizontal component. So let me show it by HE. So this is the horizontal component in horizontal direction. Okay, horizontal component. So this coil is placed with plane perpendicular to horizontal component. So this is plane. So this is horizontal component and what is the plane perpendicular? Plane perpendicular to this is this. So coil is in the perpendicular plane. Coil is already in perpendicular plane. So if coil is in this way and horizontal component in this way, so coil is perpendicular to this horizontal magnetic field. So this coil is in correct direction. Now what happens? So this is the coil. Coil is perpendicular. So a circular coil of radius this is placed with its plane. So what is the plane of this coil? If we change this circle with a square, so that is the plane. This plane is perpendicular to this horizontal component of Earth's magnetic field. Now important thing what you see, if you draw normal to this coil, that means this plane, so that is in this direction, horizontal field is also in this direction, both are in same direction, that means angle theta is equal to 0, both are in same direction. Now second time what do? They rotate it through 180 degree in 0.25 second. So time we will consider later. First let us see what is the rotation. Suppose they start rotating like this, in this way, anti-clockwise they start rotating. So what will happen after 180 degree? So let us say this x part is upper part, this y part is lower part. So after 180 degree rotation, if we rotate this, so what will happen? Coil will be something like this. This y will come up and x will go down. Again this horizontal component will remain there because we cannot change the Earth's magnetic field. Only thing, this direction which was previously at 0 degree, now the direction is this. So new angle is 180 degree. Initial angle is 0 degree, final angle is 180 degree. That is only change. Now let us solve this problem. The coil is perpendicular but normal to the coil and Earth's horizontal magnetic field have 0 angle. When rotated 180 degree, the angle become 180 degree. So these are the things we have to remember when solving these kind of problems. Now solution. Initial flux through the coil. So we have an initial flux, we have a final flux. Then we take the difference between initial and final flux and divide by time. So what is initial flux? BA cos theta. What is B? B is 3 into 10 to power minus 5. So this is the value of B. Now area. Area for a circular loop is pi r square. Pi r square, and r is equal to 10 centimeter is equal to 0.1 meter. And if we r square, what will be r square? R square is equal to 10 to power minus 1 square is equal to 10 to power minus 2. That is r square. So let us put the value of area A. A is equal to pi, r square is 10 to power minus 2. Initially what was the angle? Cos 0 degree. So let us calculate 3 into 10 to power minus 5 pi. So 3 and pi are here. This 10 to power minus 5 and 10 to power minus 2 becomes 10 to power minus 7. This much Weber. This much Weber. So this is initial flux. Now final flux. What is final flux? What is the angle for final flux? 180 degree. So the horizontal component of Earth's magnetic field will not change. So this B will remain same, 3.0 into 10 to power minus 5. This pi and r square will not change because you cannot change the size of the loop. What changes? Only angle changes. Angle becomes from 0 to 180 degree. Cos 0 is 1, positive 1, and this cos 180 is equal to minus 1. So we get same value but with minus sign. So we get minus 3 pi 10 to power minus 7. So these are the values that we get for this initial and final flux. So now let us calculate what is the change. What is the change? If you calculate phi b initial minus phi b final. Okay. So again what do we get? We get this 3 pi and minus 3 pi minus and 1 minus here, 3 pi, and this 10 to power 7 is common. So what we get? This become positive 6 pi into 10 to power minus 7. Let us put this value here. So now epsilon is equal to delta phi upon delta t. But remember, this time number of turns in coil is 500. There is not a single turn but 500 turns. So value of n is 500. This delta phi is 6 pi into 10 to power minus 7. So 6 pi into 10 to power minus 7. What is delta t? What was time? 0.25 second. So when we solve all this, we get a value 3.8 into 10 to power minus 3 volt. Again this value is very small, millivolt, 3.8 into 10 to power minus 3 volt. Now again I is equal to V upon R. V is changed by epsilon upon R. So this value is 3.8 millivolt. I is equal to epsilon upon R. Epsilon is 3.8 into 10 to power minus 3 volt, and resistance was given, R is given equal to 2 ohm. So let us put all these value. What we get? I is equal to 1.9 half of this into 10 to power minus 3 ampere. So this is in ampere. So here 3.8 millivolt, this is 1.9 milliampere. Note that the magnitudes of epsilon and I are the estimated value. Their instantaneous value are different and depend on the speed of rotation at the particular instant. So again what we have here, these values are only estimated values because we have not given that the rotational speed is uniform. Rotational speed, nowhere it is given that rotational speed is uniform. So if it also depends on the rotational speed, suppose it starts slowly then moves faster and then again slows down, so the flux change with time will change, but here we are estimating that it is moving slowly and in the this 0.25 second it completely moves. So these are only estimated values and exact values depend on the speed of rotation. So instantaneous velocities or instantaneous values will depend on the speed of rotation.